Alright, so let's dig into what asymmetric encryption is. So asymmetric encryption is an encryption form that uses two keys. It's a public and a private key, meaning that you use typically one of the keys, typically the public one, to encrypt the text, and then you can decrypt it using the private key that is associated to the public key. So these two keys are mathematically related. So the private key is related to the public key, but you cannot retrieve one of them out of the other one. So you cannot calculate or reverse one of the keys by having the other one. That's basically what asymmetric key encryption is, to put it very basic. It is a mathematically heavy calculation because it calculates huge numbers, which it puts to the power of other huge numbers. So it is very mathematically heavy. So that's why we would like to limit the usage of the phase of asymmetric key encryption. I will include a link to a video where this asymmetric key encryption and RSA-like algorithms or methods are described using the theory of colors, where you can see how mixing colors can describe the way of doing RSA or asymmetric key encryption. RSA is the method that describes how we can generate these private public key pairs, how we can share these keys over a unsecured channel, and how it can be used. So that's very like basically what it is. When we want to discuss it very briefly, it's let's say that we have these two persons, Alex and Bob, and they want to share a message. So Alex wants to send a message to Bob, and he has Bob's public key. When Alex wants to send him a message and wants to encrypt it, he takes Bob's public key, uses that to encrypt the message, and sends that over an unsecured channel to Bob. Bob uses his own private key, which is associated to his own public key, to decrypt that message, and then he'll be able to get the exact same plain text. Bob's private key is of course kept secret, so it is kept safe. It is not shared with anyone, while he can freely and publicly share his public key with anyone. So he can publish it wherever he wants, but he keeps the private key secret. That's also what happens on servers. So a server that you visit having a HTTPS. So this is, remember, this is simplified asymmetric key encryption. We'll go into a little bit more details on it later. Just want to establish the basic stuff here. So we whenever we access an HTTPS page, something similar happens. The HTTPS page has a private key which it keeps secrets, and then it gives us its public key that we can use to encrypt the message to begin with. That's the basic idea. Of course, it is a little bit more detailed when we go to HTTPS, SSL, or TLS. SSL stands for Secure Socket Layer, and it is the old implementation of HTTPS. The new one is called TLS, or Transport Layer Security. It ensures the communication between a client and a server over an insecure channel, meaning over, for instance, the internet, where we do not have by default a secure channel, and we need to be able to exchange keys and so on over that insecure channel. It is used, among other things, when communicating with bank or official web pages. Nowadays, it's actually used on most web pages. So in early days, it was used mostly on very secure pages, but now it is used on almost any web page. The public key is stored in a certificate, and the certificate is used to gain trust on that secure channel. Remember, when we get a public key, we cannot know who actually issued that, and does it belong to the person who said it belongs to. I'll give examples in a minute. I just want to establish the facts. So it uses certificates, and inside of the certificates we can find the public key. Then we have TLS. TLS is the newer version. It's more secure. It has some minor changes, but it mainly, for us, it works almost in the same way, so we won't distinguish there. A little bit more detailed. When a user tries to access a web page using HTTPS, then he will ask that web page for what supported algorithms, and send his list of supported algorithms. The server will reply with its certificate containing the public key and the supported algorithms. The browser will look at that certificate, verify that certificate on a couple of criteria. It will verify the date, the server that sent it, and it will verify that it is actually a trusted certificate. If all that is done and it works, then the public key inside of that certificate is used to in the process of actually creating a session key. So depending on what version is being used, that can be a little bit different here, but basically it's now we exchange a symmetric key. So the first part of the communication was using asymmetric, and then we go on to using symmetric encryption. I'll leave the symmetric part out of this now, because the most interesting thing for us right now is the asymmetric part. But when we are done with the asymmetric part, then we go on to using symmetric key encryption, which is a lot faster than asymmetric encryption. So now that we have symmetric encryption established, then we can send the data back and forth without that much heavy calculations.